Okay, today we're going to do a little recap of circles, which is something that we've talked about before. So hopefully we'll just recap what you remember from geometry and first semester about some circles. So one of the things that we want to do is write the equation of a circle given a center and radius, and graph circles given any center and radius. And so maybe looking at the standard equation of the circle would be a good idea. And we're just going to go right to the translated circle since we've done this before. So in this equation, the point HK is the center and R is the radius. And the equation of our circle is that we have x minus h squared plus y minus k squared, and that's going to equal r squared. So the two important characteristics of a circle are its center, again, which is HK, and our radius, which is R. Remember, look, in this equation, both H and K are opposite of what they'll appear in the equation. And please remember that the constant is r squared, not r itself. So let's just graph some circles. Let's look at example 1a. And we can see both the x and the y variable are squared, but it looks like they're in the wrong spot. So maybe if we add y squared to both sides and add 4, it would look a little better. So we have x squared plus y squared equals 4. Now that fits the standard equation of the circle. Notice that if we wanted to find the center, nothing is being subtracted from the x, nothing is being subtracted from the y, so that means that our center is at 0, 0. Notice that 4 is our r squared, and you could probably do this in your head, but if r squared is 4, we can take the square root of that. And so, and I'm just going to take the positive square root since the radius is the distance. And we can see that the radius is going to be 2. So we'll make a note that our center is 0, 0, and our radius is 2, which means that we'll go to our origin for our center. And then we go 2 units up, down, left, and right. And then we try to make a nice round circle through those points. And that's it. Letter B looks like it's in standard form, so all we would need to do is find R. And when we give R, let's give the exact value for R. So we can see once again that our center is at 0, 0. But to find our R, we're going to have to take the square root of 18. Well, 18 isn't a perfect square, but we could break it down. A perfect square that goes into 18 is 9. So we can break root 18 down into root 9 root 2. And so we can see that our radius is 3 root 2. So we'll make that note down here, that r is 3 root 2. So then how in the heck do you graph that? Well, you could look on your calculator and put in the square root of 18 or put in 3 root 2. But I think it's a little more fun to look at 18 and look to see what perfect square is that super close to. Well, 16 is a perfect square, right? And the square root of 16 would be 4. So wouldn't the square root of 18 be a little more than 4? Because the square root of 25, which is 5, would be too big. And the square root of 16, which is 4, is too small. So I'm going to graph this by starting at the origin for the center. And then I'm going to go 1, 2, 3, 4, and a little more up, down, left, and right. So a little past 4. And then I'll try to connect and make a circle. That really looks bad. And you could take the square root of 18. If you look at the square root of 18, it does end up being about 4.2. But I think going just a little more than 4 was just fine. Okay, let's do one more together, letter C. Well, this is a little more exciting. We don't just see x squared and y squared. We have an h and k value. Because we see x plus 5, that means that the h value is negative 5. And because we see y minus 1, that means that the k value is positive 1. So then our center would be negative 5, 1. Our r would be the square root of 4, which is 2. And so there's the information we can glean from that equation of the circle. So to graph it, we'll start at negative 1, 2, 3, 4, 5, 1. I think it's a good idea to mark where the center is. And then we'll go 2 units, up, down, left, and right. And then try to connect those points together to make a nice circle. Why don't you press pause and take a minute to try the you try problems. Ready, go. Okay, let's see how we did. In you try D, my center I got was 1, negative 2 with the radius of 3. And in 1E, my center was 0, 0, and my radius was 2 root 3. I noticed that 12 is between the perfect squares 9 and 16. So that means that the radius is going to be between 3 and 4. And if you did take the square root of 12 in the calculator, you can see it's just about halfway between 3 and 4. It's about 3.5. So I just went to the origin and went about 3.5 in each direction. All right? All right, so now that we've reviewed graphing circles, let's review writing the equation of the circle. Example 2a says that the point negative 4, 7 lies on a circle whose center is the origin. That's important. That tells us something. Write the standard form of the equation of the circle. Well, if the center is the origin, that means that it has the form x squared plus y squared equals r squared, since that means that h and k are 0. So to find r squared, what we could do is we could put negative 4 in for x and 7 in for y. And then since those values make this equation true, that's the way that we could find r. So we could say negative 4 squared plus 7 squared equals r squared. Negative 4 squared is 16. Remember, when you square a negative, it's positive. 7 squared is 49. And so that means that we get 65 for our value of r squared. Now, I know it's tempting to take the square root, but if we're writing the equation of the circle, aren't we using r squared? So let's not waste our time doing that, and let's just write the equation. The center was at the origin, so we know h and k was 0, so we have x squared plus y squared. And then we know that r squared is 65, so that's it. 2b is similar. It says the point 3, negative 4 lies on a circle, again, whose center is the origin. When the center is at the origin, then we can just use x squared plus y squared equals r squared. And again, it wants the standard form of the equation. So let's put 3 in for x and negative 4 in for y. So I have 3 squared plus negative 4 squared equals r squared. So that's 9 plus 16. And 9 plus 16 is 25. And again, we could find r, but r squared's in the equation, so let's just leave it. And the equation would be x squared plus y squared equals 25. And that's it. What about 2c? That one's a little different. This time, it's telling us the radius. It says, let's write the equation of a circle with a radius 2 root 7. And the center is at 5, negative 3. Well, we know that we can put 2 root 7 in for r, 5 in for h, and negative 3 in for k. So that would leave us with x minus 5 squared. Now we have y plus 3 squared. And then we have equals 2 root 7 squared. So this part of the equation is fine. We just probably should simplify this 2 root 7 squared. Remember that because this is multiplication, that means that we're going to want to square each of those factors. So 2 squared is 4. Root 7 squared is 7. So that means that 4 times 7 would be 28. So then I'll just rewrite the equation over here. We said that the left side was okay, x minus 5 squared plus y plus 3 squared. But now we know that a nicer way to write the r squared is 28. And that's the equation of your circle. So why don't you guys give you try 2D and 2E a try. Okay, let's see how we did. So for you, try 2D. Again, the center was at the origin, so I could use just x squared plus y squared equals r squared. Putting the 5 in for x and negative 1 in for y, because that's a point on the circle, I end up that r squared is 26. So the equation of that circle must be x squared plus y squared equals 26. In 2E, I knew that the radius was 3. I'm going to square that. That's where this 9 comes from. And then I just use h and k along with the x and y piece here to get that x plus 11 squared plus y minus 8 squared equals that 9. And that's it. So that's your circle recap. Hopefully that refreshed your memory and you can work on the homework the rest of the time. Have a great day.